Welcome back to the CCNA Cisco NetAcad Introduction to Networks lecture series. If you are interested in the previous lectures, I will leave a link in the description for the playlist. Today, we will be focusing on the last lecture in this ITN course, which is the module number 17, Build a Small Network. In this lecture, we will implement a network design for a small network to include a router, a switch, and end devices. We will cover devices in the small network. We will learn about small network applications and protocols. We will look into how you can scale these small networks to larger networks. And we will learn how you can verify connectivity. We will also learn host and ISO commands. Finally, we will cover troubleshooting methodologies and scenarios. And remember, this is the last lecture in this lecture series, and the main objective of this particular course and this particular lecture is to capture that everything we learned from module 1 to module 16 using this network design for a small network. Devices in a small network. Small network topologies. The majority of businesses are small, and most of the business networks are also small. A small network design is usually very simple, and small networks typically have a single WAN connection provided by DSL cable or Ethernet connection. In other words, that most of the small businesses have one ISP providing internet connection to the outside world. Large networks require an IT department to maintain, secure, and troubleshoot network devices and to protect organizational data. However, small networks are managed typically by a local IT technician or contracted out to a professional. If you get a job as an IT professional or network system specialist for a small company, you will be probably one of the few handful of people, or you will be the only person in the company that are responsible for the IT systems in that organization. Device selection for a small network. Like large networks, small networks require planning and design to meet user requirements. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. One of the first design consideration is the type of intermediary devices to use to support the network. There are factors that must be considered when selecting network devices, and they include cost, speed, and types of ports or interfaces, expandability of the network, and operating system features and services. And in my opinion, one of the biggest two factors is the cost and the users that will be using the network that you will be designing. An example of this would be if you are designing a small network for an office that has a lot of engineers working in the company, you may need a very high speed internal network. You might even use fiber optics internally, optical fiber cables, to connect between devices and intermediary devices, because most of the engineering work may require internally sharing large files, large CAD files. However, if you are designing a network for a small business that mostly deal with accounting and other things, you can use the cheapest Cat5 cable to connect those devices, and your network should be fine. So this is some of the considerations that you need to look into based on your user base. So obviously the cost of the fiber optics or optical fiber cables are much higher than the cost of the Cat6 or Cat5 cables. But if your users require that kind of a high speed connections because of large files they are sharing internally that needs to be shared as soon as or fast as possible, you may want to talk to the management about using fiber optics cables instead of Cat6, even internal LANs. So this is something that Cisco doesn't really actually highlight, but something that I've seen when I talk to IT professionals. When implementing a network, create an IP addressing scheme and use it. Because IP addressing for a small network should have a specific implementation of the IP addressing schemes to meet their needs. Just like a large network, it still applies to a small network. All hosts and devices within an inter-network must have a unique address. Devices that will factor into IP addressing schemes include end-user devices, servers and other devices, intermediary devices including switches and access points. The end-user devices are the number and the type of connections that you need to look into when you look at end-user devices, such as how many wired end-user devices going to be there, whether we're going to have a guest network with multiple wireless connections, or whether we have a corporate network with everybody on the wireless network, and how you're going to secure them, as well as the remote access such as VPN. It is recommended that you plan, document, and maintain an IP addressing scheme based on device type. The use of plan IP addressing scheme makes it easier to identify a type of device and to troubleshoot problems. So this is where your skills in VLSM, variable length IP subnet mask, VLSM, and subnetting come into play. So a lot of small companies probably don't have any idea about how the advantages or disadvantages of VLSM. There are a lot of advantages to using VLSM. As an IT professional who went through this course, you should be promoting those VLSM methods for implementing the small networks, as it will actually increase the efficiency of the network and would make it easier for you to identify the type of device and troubleshooting problems instead of using just a huge IP pool. Redundancy in a small network. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate single point of failure. Redundancy can be accomplished by installing duplicate equipment. It can also be accomplished by supplying duplicate network links for critical areas. So if you look at the diagram on the right hand side, you may have a small company with 3 servers and 2 switches and 2 routers. But by connecting these servers with multiple connection to these switches down here, what we have done is we have created redundant links between the servers and the switches. Hence, if one of these items fails, one of these links fail, the employees will still have access to these servers because there are other lines that are up and running. So the simplest way to provide redundancy is to create duplicate connections between the endpoints or the devices such as servers and the intermediary devices and the end users. Traffic management. So this is where QoS and traffic management methodologies come into play. The goal for a good network design is to enhance the productivity of the employees and minimize network downtime. The routers and switches in a small network should be configured to support real-time traffic such as voice, which are like VoIP, and video in an appropriate manner relative to other data traffic. A good network design will implement quality of service, QoS. So if you have a small business or even a large business that doesn't have QoS policies put in place in their network engineering design, that is actually a very poor design, because what's going to happen, that's going to create traffic problems within your network. Priority queuing has 4 queues. The high priority queue is always emptied first. So if you look at the priority queues shown on the right hand side here, we have 1, 2, 3, 4 queues. And with the voice having a very high priority, then followed by the SMTP, instant messaging, and FTP. And the reason why we are giving high priority to voice is that because if there is a delay in voice packets, that's going to be not usable in a VoIP network. So because we are in communication, human communication, when we are communicating with words, which is being transmitted through VoIP systems, if there's a delay in those VoIP packet switching, that would be really bad, because it's going to create jitter and it's going to create lag, and it's going to be incomprehensible for the next communication to occur, right? So that's why in properly implemented QoS, the voice packet will always get the high priority, voice and video packets. Small network applications and protocols. Common applications. After you have set it up, your network still needs certain types of applications and protocols in order to work. The network is only as useful as the applications that are on it. There are two forms of software programs or processes that provides access to network applications and application layer services. The network applications are applications that implement application layer protocols and are able to communicate directly with lower layers of the protocol stack. Application layer services, on the other hand, for applications that are not network aware, the programs that interface with the network and prepare the data for transfer. So those are two types of programs or processes that provides access to the network. Common protocols. Network protocols support applications and services used by employees in a small network. Network administrators commonly require access to network devices and servers. The two most common remote access solutions are Telnet and SSH. And we learn about a little bit in Telnet and SSH in our previous lectures. And I will go over them during my lab demonstration videos as well. Hypertext Transfer Protocol, or HTTP, and Hypertext Transfer Protocol Secure, which is HTTPS, are used between web clients and servers. So this thing actually should read HTTPS instead of just HTTP. So the secure version of the HTTP protocol, which is on port 80, uses port 443, and it is used between web clients and web servers. If you visit www.sanuja.com or sanuja.com, you will notice that I am using HTTPS, which is using port 443 for secure hypertext transfer protocol. Simple Mail Transfer Protocol, or SMTP, is used to send email. Post Office Protocol, or POP3, or Internet Mail Access Protocol, or IMAP, are used by clients to retrieve those email. In my previous lectures, I have described these processes in detail. So make sure if you don't remember them, go back and watch those videos and those lectures so you understand how Simple Mail Transfer Protocol, SMTP, and POP3 works, as well as how the IMAP is used by the client to retrieve those emails. You should be able to differentiate SMTP, POP3, IMAP, and their operations in these particular lectures. File Transfer Protocol, or FTP, and Security File Transfer Protocol, or SFTP, are used to download and upload files between client and FTP server. Again, FTP is the non-secure version and SFTP is the secure version. Dynamic Host Configuration Protocol, or DHCP, is used by clients to acquire an IP configuration from a DHCP server. Again, we have covered this in my previous lectures, and we learn how the DHCP pools can hand out IP addresses from the DHCP server to the end client when the requests go from the end device for an IP address. And if you don't remember those items, please go back to my previous lectures and watch those videos. The Domain Name Service, or DNS, resolves domain names to an IP address. As we learned before, humans are more tend to be familiar with names rather than IP addresses. So instead of giving in 192.168.10.15, for example, for sanuja.com website, you will be entering sanuja.com. That will go through a DNS server, and that will resolve to the IP address where my website is residing. Note, a server could provide multiple network services. For example, one single server could be an email server, FTP server, and SSH server at the same time. Because those services are all located in the same server doesn't mean it cannot operate at the same time. In majority of cases, in modern day, we use a single server or multiple servers in tandem that provide these multiple services instead of having one dedicated server for FTP and one dedicated server for email. So these network protocols we just covered have some fundamental tool sets that implemented in it. They include processes on either end of the communication session, types of messages, syntax of messages, meaning of informational fields, how messages are sent and expected response, and interaction with the next lower layer. So many companies have established a policy of using secure versions, such as instead of using Telnet, we will be using SSH. Instead of using FTP, we will be using SFTP. Instead of using port 80 HTTP, we will be using 443 port for HTTPS for most of these protocols, because reason for that is security is a very high priority in modern day. And whatever the protocols that we use for communication purposes and the file types that you are using to communicate and the type of messages that you will be sending, they are all part of those protocols that you will be picking for those networks. So that's what this slide is trying to get to you. So the protocols are responsible for these items, so make sure that you understand that. Voice and video applications. Businesses today are increasingly using IP telephony and streaming media to communicate with customers and business partners, as well as enabling their employees to work remotely. Especially after COVID-19 hit, a lot of small businesses and large businesses have asked their employees to work from home. And when the work from home came into play, a lot of people start using these voice and video applications to communicate during meetings and other interactions. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. The factors that a small network administrator must consider when supporting real-time applications include the infrastructure, VoIP, IP telephony, and real-time applications. So in terms of infrastructure, you should ask yourself, does it have the capacity and capability to support real-time applications such as VoIP applications or video applications? When you are implementing a VoIP system, you need to understand VoIP is typically less expensive than IP telephony, but at the cost of quality and features, you need to understand that VoIP need to have a high priority in your network. In your QoS, for example, you need to give very high priority for VoIP. IP telephony, so this employs dedicated servers that have IP telecommunication systems, such as you may have heard the HCCS, the Hosted Contact Center Solution Systems. So from a company such as Genesis, this employs a dedicated servers to form call control and signaling, as opposed to having a general purpose VoIP system that piggyback on the currently already existing networks. And I will go into detail on how VoIP and IP telephony systems work in a different lecture series that I'll be doing on my YouTube channel. If you're interested in that, make sure to subscribe and stay tuned. Then I will make sure that post those videos in the next few weeks. And finally, the real-time applications. The network must support QoS mechanisms to minimize latency issues, and the real-time transport protocol RTP and real-time transport control protocol RTCP, and two protocols that may be used by the real-time applications that you should be aware of. So when you have real-time applications, you need to make sure that your QoS, RTP, and RTCP are implemented properly. Scale to larger networks. Small network growth. Growth is a natural process for many small businesses, but I would say it's the same thing for large businesses as well. And their network must grow according to their needs. Ideally, the network administrator has enough lead time to make intelligent decisions about growing the network in alignment with the growth of the company. This actually do come into play even before you start designing the network, where you will be maybe looking at VLSM subnetting, for example. To create a network, several elements are required: network documentation, device inventory, budget, and traffic analysis. Network documentation is basically the physical and logical topologies, and the device inventory is a list of devices that use or comprise of the network. And the budget is itemized IT budget that include the fiscal year equipment purchasing budget. If you don't know how to work with those budgets, you may want to talk to the accountant of the company or hire an outside auditing team to audit your IT budgets. Traffic analysis is the protocols, applications, and services and their respective traffic requirements that should be documented through the traffic analysis information. So these elements are used to inform the decision making that accompanies the scaling of a small network. It is important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for this purpose. To determine traffic flow patterns, it is important to do the following. Capture traffic during peak utilization times to get a good representation of the different traffic types. So if you are monitoring a network, don't just capture the traffic at midnight or at 5 p.m. when most people are leaving the office. You probably want to capture the traffic around whenever the peak times. So if it is a 9 to 5 jobs, don't even capture traffic at noon because maybe most people are on lunch breaks. So you need to consider those factors when you are capturing peak utilization times traffic, right? And then perform the capture on different network segments and devices, as some traffic will be local to a particular segment. So if you have, for example, different departments such as engineering, accounting, and business departments in the same company, you may want to capture those traffic separately in different segments so that you can understand the traffic flow in different departments. Information gathered by protocol analyzer is evaluated based on the source and destination of the traffic as well as the type of traffic being sent. So you can also capture the traffic protocol information. So for example, if the accounting department may rarely use FTP, but the engineering department may be sending large file to FTP server. That is a really good example of information gathered using protocol analysis. So we know the engineering department need more access to FTP servers and need more bandwidth in the FTP protocol than the accounting department, for example. So this analysis can be used to make those decisions on how to manage the traffic more efficiently. So those are the key things that you should get out of this particular slide and may show up on your Cisco, CCNA, CCNP exams. Employee network utilization. This is where one of the places where human factor play a major role. So many operating systems provide built-in tools to display such network utilization information. These tools can be used to capture a snapshot of information that may include the operating system and operating system versions, especially if you have a bring your own device type of network where employees bring their devices from home. They might have different operating systems and versions than what is being typically used in your small and large networks. CPU utilization, RAM utilization, drive utilization, non-network applications. It could be a specific applications used by the company that may not be network connected but have an impact on how the employee is interacting with the network as a result of that application. Network applications, those are obviously going to have a direct impact on your network. And what is important here is the documenting snapshot for employees in a small network over a period of time is useful to identifying evolving protocol requirement and associated traffic flows. I seen a lot of time network engineers and IT technicians either being underpaid or not given enough time to capture data in a long period of time. So what happened is they were paid for 1 day of work, so they go ahead and capture those data, but that may not be representative of what actually happened within a week, within a month, or within a couple of months of that company. So that is very important. It's not just documenting those snapshots, but also documenting those snapshots on a over a period of time. That is very important. Verify connectivity. Verify connectivity with ping. Whether your network is small and new or you are scaling an existing network, you will always want to be able to verify that your components are properly connected to each other and to the internet. The ping command, available on most operating systems, is the most effective way to quickly test layer 3 connectivity between a source and a destination IP address. The ping command uses the Internet Control Message Protocol, known as ICMP, echo, which is ICMP type 8, and echo reply, which is ICMP type 0 messages. So most of us are familiar with how the ping commands work. Basically, especially on Windows machine, you go ping and you enter the IP address, and it is using the ICMP protocols as we covered in our previous module to send that request to the destination IP address and use the ICMP type 8 and ICMP type 0 messages to make sure to test that connectivity between your host device and the destination device. If you would like to learn more about the ICMP, which you should be familiar with, you can go ahead and watch my previous lecture that is dedicated to the ICMP module. On Windows 10 host, the ping command sends 4 consecutive ICMP echo messages by default and expect 4 consecutive ICMP echo replies from the destination. On Cisco iOS ping send systems, what's gonna happen is it by default send 5 ICMP echo messages and displays an indicator for each ICMP echo reply. So in Windows machines, when you send a ping command, by default it will automatically send 4 consecutive ICMP messages, while in Cisco ISO devices, when you send the ping command, by default it will send 5 consecutive ICMP messages. In my lab demonstration, I will show you how you can either increase or decrease the number of pings being sent when you are trying to test a destination device using the ICMP command. But what you need to remember for your exams is by default it is 4 for the Windows and 5 for the iOS as of now. The iOS ping command indicators are these. So we have exclamation mark, dot, or a U. So when you send an ping command on iOS, you have, if you end up with a bunch of exclamation marks, that means there is a successful receipt of an echo reply message, and it validates a layer 3 connection between the source and destination. In other words, your ping was successful. A period, which is a dot, it means that is a time that is waiting for an echo reply message by your ISO device, and it indicates a connectivity problem occurred somewhere along the path. And a uppercase U indicates a router along the path responding with an ICMP type 3 destination unreachable error message. And the possible reason why that could happen is that the router doesn't know the direction to which the destination network is, or it couldn't find the host on the destination network. And remember, there are other types of possible ping replies on iOS devices. There are Q, M, question mark, and so on. However, you do not need to know in depth the meaning of these things for this particular course, but you should be familiar with at least these 3 elements of ISO ping indicators. On my demonstrations that I'm going to show you for labs associated with these Cisco classes, I will show you how you can figure out all of these replies and indicators using the help command on the ISO. But for now, just remember at least these 3 for your exams and quizzes. Extended ping. The Cisco offers an extended mode of the ping command. The extended ping is entered in privileged executive mode by typing ping without the destination IP address. So you just enter ping and hit enter instead of entering an IP address. You will be then given several prompts to customize the extended ping. Note, the pressing enter accepts the indicated values. The ping IPv6 command is used for the IPv6 extended ping. So if you want to go into the IPv6 extended ping, what are you going to do? You're going to put ping and then enter IPv6. So you enter ping IPv6, you type it out and then press enter. That will get you into the IPv6 extended ping. As I mentioned before, the extended ping in this example is allowing you to change how many pings you can send and repeat count. For example, by default it's sitting at 5, but you can change it to 100, 10, 15, whatever you need to test your network. You can change it in this extended ping. And some of the examples of the indicators are shown underneath here. See, this is actually showing that the ping is being sent, and then it shows and been successfully received on the other end, and it shows the success rate of 100%. One thing I should point out, when you are testing a ping command, it might take time for ARP and other protocols to wake up when you first send the ping command to a device on your network from your host device. So the first ping or the first few pings may drop. So again, it doesn't indicate a problem with your network. It's probably indicating that it's still running an app. So I will actually show you an example of that in my lab demonstration. So don't expect this ping to be always at 100% when it starts sending. And just because of it is not 100% success doesn't mean there is a connectivity problem, because it may be running through the ARP and other protocols as you send your first ping out from your host to the destination. In other words, another way of explaining this is basically the system may be still waking up to create this ping request, so your first ping may get dropped as a result. Verify connectivity with traceroute. The ping command is useful to quickly determine if there is a layer 3 connectivity problem. However, it does not identify where the problem is located along the path. So you will get a return ping error. There may be an error message on your ping command, but you will not know that there's no way to figure out where the connectivity issue is happening if there is an issue. So the trace route can help locate layer 3 problem areas in a network. A trace returns a list of hops as a packet is routed through a network. Remember, a hop is like usually a router that basically kind of logically divide your network into separate pieces. That's why we call it one next hop. So a trace route would be able to return a list of hops as the packet is routed through the network. A syntax of the trace command varies between operating systems. So for example, if you have a Windows 10 or a Windows 11 PC, how you're going to do a trace route is basically you're going to type on command prompt trace RT, and then you enter the IP address. So trace RT, where that stands for trace route in Windows, and then you enter the IP address of your destination, in this case 10.1.1.10, and that will get you a trace route going on your Windows machine. But if you have a ISO device, in this case a Cisco router in this example, what you need to use is the command trace route. So it's a one word as trace route, and the IP address of the destination device. And that will get you the traceroute command in Cisco devices. So depending on the operating system, you have to know which command to use for the traceroute, and that will get you the information that you needed through the traceroute command. Next, we're going to look at an example of a traceroute command down here. Before that, there's a quick note up here. Is you can use CTRL-C to interrupt a traceroute in Windows. You can actually do that to interrupt a ping as well. So if you're sending 100 pings to a destination because you're testing something, but you after about 30th ping you did realize, okay, you know what's wrong with it, you can use CTRL-C to interrupt it. And the same will go for the traceroute in Windows. So that's what the comment up here. The only successful response in this example is from the router 1, because if you look at down here, we have 1, 2, 3, 4 hops. So those are 4 routers, and we have only success here from the first hop, which shows a 2 millisecond return, and then it will have it has the IP address of that return, right? So the trace request to the next hop timeout as indicated by the asterisk right here, meaning that the next hop router did not respond, or there is a failure in the network path. In this example, there's appear to be a problem between the router 1 and router 2. So there's a problem between this router and the next router, and being timed out each time. So this is a good example of traceroute is being used to check network connectivity between 2 devices. The following are sample outputs of traceroute command from router 1. So we have traceroute 10.1.1.10, which is the same one in here as well. And there are 2 different screens showing up here. On the left, the trace validated that it could successfully reach PCB. So they are trying to reach the PCA to PCB. So the PCA is router 1 is trying to reach the PCB, and it can successfully reach it because it shows it's been returned, right? On the right hand side, however, the 10.1.1.10 was not available, and the output shows asterisks where replies timeout. Timeouts indicate a potential network problem. So you actually have the ping go through, the traceroute command go through the first 2 hops, and then it start timing out. So you can use CTRL-Shift-6 to interrupt a traceroute in a Cisco iOS device, just like CTRL-C on the Windows device. So you can interrupt with the CTRL-Shift-6 together, number 6 will together to interrupt a traceroute. And again, they indicate here in a note, in a Windows implementation of the traceroute or tracecert sends ICMP echo request, while the Cisco ISO and Linux use UDP with an invalid port number. The final destination will return an ICMP port unreachable message. So that's another difference between a Windows and a Cisco device or a Linux device. Do these items show up on your Cisco NetAcad exams? Yes, it will. You might get an example, show a screen showing a traceroute command on a Cisco device, iOS device, and a traceroute command showing a Windows device, and you should be able to identify items within those for your exams and quizzes. Like the extended ping command, there is also an extended traceroute command. So in this slide, we're going to be looking at a little bit into the extended traceroute. It allows the administrator to adjust parameters related to the command operation, just like we did with the extended ping command. The Windows tracecert command allows the input of several parameters through options in command line. However, it does not guide like the extended traceroute iOS command. So in other words, you need to know what you need to enter as you enter that tracecert command into your Windows terminal. So when you go to Windows command prompt, you have to go tracecert and then enter whatever the options right after it before hit enter. So the following output display the available options for the tracer command. So what you can do actually, tracer / will give you all the available options. However, in Cisco iOS, extended trace route options enables the users to create a special type of trace by adjusting parameters related to the command operation. Extended trace route is entered in privileged executive mode by just simply typing trace route and then hit enter without entering the IP address. So unlike the Windows, where you need to know what you need to enter next, or you had to go through this command so you can see what are the options you have, and you can re-enter trace cert and then enter one of those options. In iOS, Cisco iOS, it allows you to just simply enter trace route and press enter, and it will give you the options to modify the extended trace cert. And remember, just like the extended ping, pressing enter accepts the indicated default value. For example, in here, timeout in seconds is by default 3. That's what the default is shows in these brackets. Because this person did not enter any value in this timeout seconds, like 10 seconds or 5 seconds or even 1 second here, what's going to happen is by entering enter here with nothing in this value field, it's going to take that default value. By pressing enter, it accepts the default value of 3 in timeout in this example for your reference. Network baseline. So now we're going to talk about how network baselines work. So one of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. One method for starting a baseline is to copy and paste the results from an executed ping, trace route, or other relevant commands into a text file. These text files can be timestamp with the date and save into an archive for later retrieval and comparison. So basically you can do once in a while pings or trace routes and then copy those data and save them in a chronological order, so you can go back and check if there are issues in your network in different times. Among items to consider are error messages and response times from host to host. Corporate networks should have extensive baselines, more extensive than we can describe in this particular course, but should have very extensive way of looking at baselines. Professional grade software tools are available for sorting and maintaining baseline information. In fact, there are dedicated software for network monitoring that are used in corporate and large scale networks. We will not cover those softwares and options in this particular course, but I will post a separate video comparing different options available for network engineers and administrators when you are trying to create baselines for corporate and large scale networks. There is a lab available on your Cisco NetAcad called Test Network Latency with Ping and Trace Route. If you have access to your Cisco NetAcad, please log into your Cisco NetAcad and do this lab. If you do not have access to Cisco NetAcad, I will try to find a copy of these labs and post to my website so you can download it. And if I find it, I will leave a link in the description of this video. Host and iOS commands. IP configuration on a Windows host. In Windows 10, you can access the IP address details from Network and Sharing Center to quickly view the 4 important settings. They are address, the IP mask, router, and domain name server IP address or information. Or you can issue the IP config command at the command line of the Windows computer, which is the command prompt. Use the ipconfig/all command to view the MAC address as well as the number of details regarding the layer 3 addressing of the device. So if you just run ipconfig, it's just going to show you the IP addresses and the default router, for example. But if you go ipconfig/all, it will show you the MAC addresses and some additional information. If a host is configured as a DHCP client, the IP address configuration can be renewed using the ipconfig/release and ipconfig/renew commands. You can actually enter both of those commands in one line. And how you do it, basically, you're going to put ipconfig/release and you're going to put ampersand and like ampersand and like the two ends, and then ipconfig/renew, and that will get you that. Again, I will do you a quick demonstration of these commands on a Windows machine and post on my YouTube channel as a lab demo later this week. The DNS client service on Windows PCs also optimizes the performance of DNS name resolution by sorting previously resolved names in memory. The ipconfig/display DNS command displays all of the cached DNS entries on a Windows computer system. So you should be familiar as a network technician, as a network engineer, as a network student, you should be familiar with all of these commands, because Windows 10 and Windows 11 and Windows computers and servers are very common at most computer networks nowadays. So in this example down here, they have an image of ipconfig command displaying some information about the IPv4 address, subnet mask, and the default gateway. IP configuration on a Linux host. So some of your machines at work or your office or your school will be using Linux. They are very common machines. Linux are very common machines, especially for servers. So this is something you also should be familiar with. Verifying IP settings using the GUI on a Linux machine will differ depending on the Linux distribution and the desktop interface, because there are many different types of Linux such as CentOS, Ubuntu, ArcOS, etc., etc. The GUI may differ. However, on the command line, you can use the ifconfig command to display the status of the currently active interfaces and their IP configuration. The Linux IP address command is used to display the IP addresses and their properties. It can be used to add or delete IP addresses by using the IP address command. The newer Linux also have the ability to take the command called IP. You can simply enter IP and enter, and that or IP-A. That will also give you an IP address. So Linux is a little bit of cumbersome sometimes because it is fragmented and there are many different vendors and many different packages that you can install on top of the Linux base operating systems to modify how ipconfig and IP address lookup works. Again, I will go into detail about this on a separate video. But note the output display may vary also depending on the distribution as well. Again, I will show you a live demo video and post it to my YouTube channel so you can check that out. In the GUI of a Mac host, open network preferences, and if you go to advanced in the network preferences, you can see the IP addressing information. The ipconfig command can also be used to verify the interface IP configuration at the command line on a Mac OS. Because Mac OS is based on a Linux Unix framework. The other useful Mac OS commands to verify the host IP settings include the network setup - list network services and network setup - get info. That will, and with the particular network service, that will also give you the IO Mac OS examples. And again, I will go through them on a video and I will quickly cover them on a separate video. The ARP command. The ARP command is executed from the Windows, Linux, or Mac command prompt. The command lists all devices currently in the ARP cache of the host. And remember, we cover ARP in a previous module. And if you don't remember what the ARP does and how ARP works, please go back and check my YouTube channel's videos on ARP related to this particular lecture series, and you should be able to watch that video and get an idea about how ARP works. The ARP-A command on a Windows machine displays the known IP address and MAC address binding. The ARP cache only displays information from devices that have been recently accessed. So if you enter ARP-A command, it will give you the IP address and the MAC address binding available in the ARP table of your Windows machine. And however, it only displays the cache information available on that device that has been recently accessed, okay? Because ARP table get refreshed and deleted depending on how the configurations and the network works. To ensure the ARP cache is populated, ping a device so that it will have an entry in the ARP table. So when you first boot up a computer, you can ping a device and then check the ARP-A so that it will have that data on the ARP table. The cache can be cleared by using net's interface IP delete ARP cache. So NETSH interface IP delete ARP cache command will clear the ARP table, and that can be used in the event the network administrator wants to repopulate the cache with updated information. So that is something that a lot of network administrators and technicians do. They will run this command to clear the cache and then the ping and then do ARP-A. Note, you may need administrator access on the host to be able to use NetSH interface IP delete ARP cache command. So you may be able to do the pings and ARP-A, but you may not be able to do the NetSH interface IP delete. You may not be able to delete the ARP cache table. Depending on your privileges. So especially with Windows ADDS, where you have a domain controller with certain privilege controls to the end user, if you are not an administrator or you have not logged in as an administrator, you may not be able to clear the ARP cache. So that's something that you should know. So the common show commands we went through is in the past through our labs, which again I will post later on my YouTube channel, is the show running config, show interface, show IP interface, show ARP, show IP route, show protocols, and show versions. So these are all common iOS commands that you can use on your Cisco devices to look up various different items on a network. Now, I'm not going to go through all of them right now. So if you would like to know what all of these do, you can pause this video on this screen and look it up in the description. We did cover this during past modules. And again, I will go through some of these labs later on my YouTube channel, so you could see how you can actually use them in a live demo. The show CDP neighbors command. CDP provides the following information about CDP neighbor device. In iOS, the devices, what we do is we go show CDP neighbors. That's how we figure that out. So the CDP command, allow you to give you some information about device identifiers, address list, port identifier, capabilities list, and platform information. So the device identifiers is the configured host name of a switch, router, or other device. Address list will show up one network layer address for each protocol supported. Port identifier give you the name of the local and remote port in the form of ASCII character string, such as fast Ethernet 0/0, for example. Capabilities list whether a specific device is a layer 2 switch or a layer 3 switch. Platform, which shows some hardware information as the hardware platform of the device. So the show CDP neighbor detail command is shown in here on the bottom right here. And when you have in a Cisco device and you go show CDP neighbors and you press enter, and this is something that shows up as a result. So it has the port information. So in here gig 001, and it will give you some information about capabilities, platform, which is using WS-C2960 plus platform, and it will give you some port information. So that's what the CDP neighbor command does. the show IP interface brief command. Again, this is a command that being used on Cisco ISO devices, and this is one of the most frequently used commands. And this command also provides more abbreviated output than show IP interface command, and it provides a summary of the key information of all network interfaces on the router. So when you go show IP interface brief, it's going to show summary of all the interfaces and whether they are assigned, and if it is assigned, the assigned IP address, and whether the port is up or down. So that's what the show IP interface brief does, as opposed to show IP interface command. So it shows a more summary, a detailed description. So that's what is showing up here. There is a video available on your Cisco NetAcad called show version command. If you do not have access to your Cisco NetAcad, I have a copy of that posted on my YouTube channel. I will leave a link in the description, and I will also leave a card at the top right hand corner. You can go ahead and watch that video, and that will give you an idea about how the show version command works. There is a packet tracer file, a lab called interpret show command output. Again, if you have an access to the Cisco NetAcad material, go ahead and do them. If you do not, I will try to find a copy of that and post to my website and leave a link in the description for you to download and practice. Troubleshooting methodologies. So finally, we're going to look at some troubleshooting methodologies. This is a brief overview for this particular course. There is a separate course associated with troubleshooting network issues that I will do in the future in this YouTube channel. So make sure to subscribe to my channel so that you don't miss one of those videos. But for now, we're just going to brush through just the overview of how you can approach troubleshooting network related issues. That's what we're going to cover in this particular lecture, because that is exactly what the Cisco NetAcad people and the Cisco examination people are looking for CCNA 1 Introduction to Networks lecture series, right? That's what this is actually all about. But again, I will do a comprehensive network troubleshooting course on my YouTube channel later this year. So let's look at the basic troubleshooting approaches. So the very first step is to identify the problem. Next is to establish a theory of probable causes. And the next is to test the theory to determine the cause. Then we're going to establish a plan of action based on that theory and implement a solution. And then verify and implement preventative measures. Finally, the most important part, especially if you are working for a large company, is to document your finding, actions, and the outcomes. So it is properly documented. When this happens the next network engineer or technician can look up those documents and reference that material. So to identify the problem, that is the first step. So you need to figure out what tools can be used to identify that problem, and make sure that you go through the proper processes to identify that problem. And once you know that that problem, you should be able to establish a theory of probable cause. So what I'm trying to get at you here is that you should, as a especially junior network technician, a junior network engineer, you should go through these 6 steps every single time, because once you become senior, you may be able to skip some of these steps too, which is not recommended by any industry professional. But, especially when you are starting out in network engineering and network technology systems, you should follow these 6 steps in terms of troubleshooting network issues. So I'm not going to go through every single steps and describe them. If you would like to know the description, you can pause this video in this slide and read the description here. But what you need to understand is you should go through one step at a time and not skip any of them, especially if you are new to the job and if you are new, IT technician. So you need to figure out the issue needs to be resolved or need to be escalated, right? So in some situation, it may not be possible to resolve the problem immediately. A problem should be escalated when it requires a manager decision, some specific expertise, or network access level unavailable to the troubleshooting technician. So you may have a company policy that clearly state when and how a network technician should escalate a problem. So if you have that policy, make sure that you follow them. This is where, sometimes the tier 1 versus tier 2 versus tier 3 technicians come into play. You may be a tier 1 agent. You may not be able to do the troubleshooting because you don't have network access capabilities that you needed to do the troubleshooting, or you need a higher, like a manager level authority to action whatever need to be action in order to resolve the problem. That's why you need to decide, you need to escalate the issue into the higher levels. So what really important here, you follow the company policy that clearly state how these should be escalated. So after the evaluation, if something needs to be escalated, make sure you follow the company policies to do so. The debug command. In iOS, there's a debug command that allows the administrator to display operating system process, protocols, mechanisms, and event messages in real time for analysis. All debug commands are entered in privileged executive mode. The Cisco iOS allow for narrowing the output of debug command to include only relevant features or sub-features, so that you are not overwhelmed by a whole bunch of debug commands from everywhere. All the features that the iOS have, you have the ability to narrow it to whatever the features or sub-features you are looking at. Use the debug commands only to troubleshoot specific problems, so that you don't have an overwhelming list of information that you don't understand. To list a brief description of all the debugging command options, use the debug and space ? Command in the privileged executive mode at the command line. To turn off a specific debugging feature, add no keyword in front of the debug command. Alternatively, you can enter the undebug from the command in privileged executive mode. That will undebug, that will everything in the debug command list. To turn off all active debug commands at once, use the undebug all command. That will also result in the same. Be cautious using some debug commands, as they may generate a substantial amount of output and use a large portion of system resources. The router could get so busy displaying debug messages that it would not have enough processing power to perform its network functions or even listen to commands to turn off debugging. So this is a caution that I need to highlight to everybody who is new to Cisco devices or who is just learning how to become a network technician. You have to be very careful when you are using debug command on an active device. So a device that is in production or in active mode, that is in production in an environment such as an office or a home office or a network that is currently being used by multiple users. You should be very careful using debug command, because the sheer volume of data that can produce with this debug command on an iOS device, such as a router, could result in not having enough processing power to perform its basic network functions that are, should be doing, such as routing. That would disrupt network connectivity to your users and administrators. So be careful with your debug commands in iOS devices. The terminal monitor command. Debug and certain other iOS message output is not automatically displayed on remote connections. This is because log messages are prevented from being displayed on VTY lines. To display log messages on a terminal, which is a virtual console, use the terminal monitor privilege executive command. So you need to enter terminal monitor command, and that will actually give you the information you need. To stop logging messages on a terminal, use terminal no monitor in the privilege executive mode. Remember that no command, you can put it in front. So you can put terminal no monitor. Instead of terminal monitor, you put terminal no monitor. That will actually stop the logging messages. On the right hand side of your screen shows what the terminal monitor look like. So you can put terminal monitor and then ping whatever you want to ping, and it will give you those terminal messages as well. Again, I will go through these examples in a real live lab environment and post that video to YouTube later sometime. Troubleshooting scenarios. Duplex operation and mismatch issues. Interconnecting Ethernet interfaces must operate in the same duplex mode for best communication performance to avoid inefficiency and latency on the link. On my previous modules, I have explained on my previous lectures how and why it is super important that the duplex mode is properly configured on all the devices of your network. So that's what this is all about. So interconnecting Ethernet interfaces must operate on the same duplex mode for higher performance. The Ethernet auto negotiating feature facilitates configuration, minimize problems, and maximizes link performance between two interconnecting Ethernet links. So the auto negotiating feature can determine the duplex mode when communicating with another network device. The connected devices first announce their supported capabilities and then choose the highest performance mode supported by both ends. If one of the two connected devices is operating in full duplex and the other is operating in half duplex mode, a duplex mismatch occurs. While data communication will occur through a link with a duplex mismatch, the link performance will be very poor. So in other words, just because of you have a duplex mismatch between devices in your network doesn't mean the communication completely gonna drop. Obviously, the data communication will occur through that link. However, the duplex mismatch will significantly hinder the performance of your network. Duplex mismatches are typically caused by misconfigured interface or, in rare instances, a failed auto negotiation. Duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs. So you may have a poor performing network and you would not be able to figure out where the duplex mismatch is happening unless you go through step by step and figuring out where the duplex mismatch happens. And just to let you know, this is one of the most common errors, most common issues in the real world, in the field, as you work as a network technician or network engineer. IP addressing issues on iOS devices. So the two common causes of incorrect IPv4 assignments are manual assignment mistakes or DSCP related issues, because there are two ways of assigning IP addresses to a device. Network administrators often have to manually assign IP addresses to a device, such as servers and routers. If a mistake is made during the assignment, then communications issues with the device are very likely to occur. On an iOS device, use the show IP interface or show IP interface brief. This one, show IP interface or show IP interface brief commands to verify what IPv4 addresses are assigned to the network interfaces. For example, using show IP interface brief command, in here down on your screen, it shows the interface statuses on router 1. So we enter show IP interface brief and it shows different interfaces listed here and the IP addresses associated with it if it is assigned and what is the status of that IP, whether it's up or down. IP addressing issues on end devices. On Windows-based machines, when the device cannot contact a DHCP server, in other words, it is unreachable, Windows will automatically assign an IP address belonging to the 169.255.00/16 range. This feature is called Automatic Private IP Addressing, or APIPA. We briefly cover APIPA on a previous module, and I will also go through them in a lab demonstration later. A computer with an APIPA address will not be able to communicate with other devices in the network because those devices will most likely not belong into the 192.254.0.0/16 APIPA network. Other operating systems such as Linux and Mac OS do not use APIPA, but the Windows does. If the device is unable to communicate with a DHCP server, then the server cannot assign an IP address for the specific network and the device will not be able to communicate. So to verify IP address assigned to a Windows-based computer, we use the ipconfig command, which we went over on our previous slides. Again, I will describe APIPA in a little more detail in a different video. For now, for your exams, what you need to remember is if they give you a screenshot with a 192.254.0.0/16 range, you should be able to identify that as an APIPA address and a failure to reach DHCP as one of the answers on your Cisco NetAcad or Cisco final exams. Default gateway issues. The default gateway for an end device is the closest networking device belonging to the same network as the end device that can forward traffic to other networks. So that's a very key important detail that you should remember. The default gateway by definition for an end device is the closest networking device belonging to the same network as the end device that can forward traffic to other networks. If a device has an incorrect or non-existent default gateway address, it will not be able to communicate with devices in remote networks. Similar to IPv4 addressing issues, default gateway problems can be related to misconfiguration. So in the case of manual assignment or DHCP problems, if automatic assignment is in use, the default gateway failures usually happen because it couldn't find the DHCP server or other information that it needed that has to be manually assigned with that default gateway IP addresses. To verify the default gateway on Windows-based computers, use the ipconfig command. On a router, use the show IP router command to list the routing table and verify that the default gateway known as default route has been set. So in iOS devices, show IP route command will show you something called the default route, and that is actually the default gateway for that router. This route is used when the destination address of the packet does not match any other routes in its routing table. Troubleshooting DNS issues. It is common for users to mistakenly relate the operation of an internet link to the availability of the DNS. So I'm going to repeat that again. It is common for users to mistakenly relate the operation of an internet link to the availability of DNS or domain name services. So domain name services are provided by a DNS server, and the DNS server addresses can be manually or automatically assigned via DHCP, Dynamic Host Configuration Protocol. Although it is common for companies and organizations to manage their own DNS servers, any reachable DNS server can be used to resolve names. Cisco offers OpenDNS, which provides secure DNS service by filtering phishing and some malware sites. OpenDNS addresses 208.67.222.222 and 67.222.222.222. So that's the Cisco one, but you may have heard 1.1.1.1, for example. That's another OpenDNS that are available. Advanced features such as web content filtering and security are available to families and businesses through the Cisco OpenDNS option. But yeah, obviously there are other ones too. For example, Google use 8.8.8.8 open DNS. It's a type of DNS that publicly available. I keep saying open DNS. There's actually what we call the public DNSs. So 1.1.1.1 and 8.8.8.8, which 8.8.8.8 is from Google, is public DNSs. So in Cisco, public DNS is called open DNS. The DNS service providers, so in this case, for example, Cisco can add value to those services by providing security, for example, in this case with OpenDNS. The use of ipconfig/all in a Windows device can verify the DNS server and which is in use on a Windows computer, while the nslookup command is another useful DNS troubleshooting tool that can be used on a Windows computer. And with the nslookup, a user can manually place a DNS queries and analyze the DNS response and hence use that for troubleshooting. Again, there is a lab called Troubleshoot Net Connectivity Issues. And if you would like to work on those labs, if you have access to the Cisco NetAcad, please go ahead, download those labs and do them. And I will try to get a copy of that lab and post it to my website, and I will leave a link in the description if I do so. There's another lab called the Troubleshoot Network Connectivity Issues. Again, if you have access to Cisco NetAcad, go ahead, download them and do them. And if you do not have those access, I will try to find a copy of those labs and post to my website and leave a link in the description. Finally, this would bring us to the end of this lecture, and I will quickly go over what we have learned in this particular module. Again, there is a lab called Design and Build a Small Business Network. If you have access to the Cisco NetAcad, this will cover everything we covered in this particular lecture, and it will help you understand everything we went over. But if you do not have access to this lab, I will try to get a copy of this lab and post to my website, and I will leave a link in the description so you can go ahead and download and do them. There's another packet tracer file that will cover everything that we covered. It's called Skills Integration Challenge. If you do not have access, again, I will find a copy of that, post it to my website, and leave a link in the description so you can go ahead and download and do them. Another lab called the Troubleshooting Challenge. So make sure that you go ahead and do them. Again, I will post a link in the description if you don't have access to these labs, so that you can download them, do them later. And if I do these labs myself, I will make sure to record them and post a video on the YouTube. So make sure to subscribe to my channel and thumbs up this video so that more people see this video and can see this lab demonstration that I will post later down the line. So finally, here's a brief to a couple of slides on what we have learned and covered in this lecture. We learned factors to consider when selecting network devices for a small network: cost, speed, and types of port interfaces we need, the expandability that needed for that particular organization, and the operating system features and services. We learned when implementing a network, create an IP addressing scheme, such as using VLSM, and use it on end devices, servers, and other connected intermediary devices. Redundancy can be accomplished by installing duplicate equipment, but it can also be accomplished by supplying duplicate network links for critical areas, such as a server could have multiple network interfaces that is being used to connect that server to the network. So if one link goes down, the server is still up because the other links are up. The routers and switches in a small network should be configured to support real-time traffic such as voice and video in an appropriate manner relative to other traffic data. That's where the QoS model come into play. Again, in this particular lecture and this particular course, we do not go into in depth of how QoS works. That is a separate course that I will cover later on my YouTube channel. And there are two forms of software programs or processes that provide access to the network. That includes the network applications and application layer services. Make sure you know how to separate the network applications from application layer services. If a Cisco exam have a description of an application and ask you whether it's a network application or application layer services. We also learn how you can scale a network. Several elements are required to do that. Those include network documentation, device inventory, budget, and traffic analysis. We also learn about the ping command. That is the most effective way to quickly test a layer 3 connectivity between a source and a destination IP address. We also learn the Cisco iOS offers an extended mode of the ping command, which sets the user with a special type of pings by adjusting different parameters in the ping command. Trace returns a list of hops as a packet routes through network. So we learn about that trace returns in this lecture, which is the trace route command, and that will give you the hops. Like you remember, hop is a router with routers within a network between you and the item that the device that you try to reach. Sometimes there are also layer 3 switches, which I will go into detail in a different lecture. There is also an extended traceroute command. It allows the administrator to adjust parameters, just like we can adjust parameters for ping command with the extended ping command. You can do the same thing with extended traceroute command, and that will allow you some parameters to be adjusted with the traceroute command. Network administrators view the network administrators view the IP addressing information such as address, subnet mask, router, and DNS on a Windows host by issuing ipconfig command. Other necessary commands are ipconfig/all, ipconfig/release, and ipconfig/renew, and ipconfig/display DNS. Again, I will go through them in much more detail on a live lab demo video later. Verifying IP settings by using graphical user interface can be done. You can verify the IP settings using a graphical user interface on Linux machine, but it differ from different distributions of Linux, because the Linux field is pretty much fragmented. The operating systems are highly fragmented. Necessary commands are ifconfig and IP address, and there's a IP-A. Remember that command, that is another command that you can use for Linux. Again, I will go through them on a live demo. In the graphical user interface of a Mac operating system, you can open the network preferences in Mac machines and go to advanced, and then there you can see the IP addressing information. Other IP addressing commands for Mac machines are ifconfig, because it's based on Linux and Unix systems, and the network setup dash list install network services, and network setup dash get info. Then you enter the network service information on Mac machine, and that will give you that information. The ARP command is executed from Windows, Linux, or Mac command prompt. It's the same command, just ARP. The command lists all devices currently in the ARP cache of host, which includes the IPv4 addresses, physical addresses, and the type of addressing, which is dynamic or static for each device. But remember, ARP-A command displays the known IP addresses and MAC address binding. So if the ARP table doesn't have that information, it won't be able to display that information on ARP command, even though that device may be still within your network. The common show commands are show running config, show interfaces, show IP address, show ARP, show IP route, show protocols, and show version. The show CDP neighbor commands provides the following information about each CDP neighbor device, which are identifiers, lists, the IP address list or address list, port identifiers, capabilities list, and platform. which is the platform of the iOS device. So these commands are associated with the iOS Cisco devices. The show CDP neighbors detail command will help determine if one of the CDP neighbors has an IP configuration error. The show IP interface brief command output displays all interfaces on the router, the IP addresses assigned to each interface, if it is available, and the operational status of the interface. Again, show IP interface brief is part of the Cisco ISO devices. The 6 basic steps to troubleshooting. Remember, the step 1 is to identify the problem. Step 2 is to establish a theory of the probable causes. Step 3 is to test the theory to determine the cause. Step 4 is to establish a plan of action and implement the solution. And step 5 is to verify the solution and implement preventative measures. And finally, in step 6, we document our findings and the outcome. For this course, you need to remember those steps for your exams and quizzes, but not much in detail. As you go into the field as IT technicians and engineers, you will be using those steps initially, at least, to make sure that you follow proper protocols and procedures. So that's very important. And each of these steps is depend on the previous step below. For example, steps 2, establish a theory of probable causes. Remember, it depends on you properly identifying the problem in the step 1, and so on and so forth. So remember that for your exams and quizzes and your future networking career. Another thing we learn, a problem should be escalated when it requires a decision of a manager, some specific expertise such as a tier 2, tier 3 agent involvement. If you are a tier 1 agent, it needs to be escalated, or network access level unavailable to the troubleshooting technician. So it's not just a network access level, but also the system access level. So if you are a network engineer working on a Windows server and you are troubleshooting issues, you may not have the capabilities to perform a specific task because you don't have the access level that needs to be, in that case, escalated to the next level. Operating system processes, protocols, mechanisms, and events generate messages to communicate their statuses. The iOS debug command allows the administrator to display these messages in real time for analysis. So remember the iOS debug command. Be very careful with those log messages, because if you are running iOS debug on a operating like a real world production environment, that could actually hinder the day-to-day operations of that network, because you are running those whole bunch of debug commands. So be careful with that. To display log messages on a terminal, we use the command in the privilege executive mode, then that will allow you to display the log messages in that virtual console. And that is the end of this lecture. If you like this type of lectures and if you like to watch more of these, please make sure to thumbs up this video and subscribe to my channel. And if you have any questions or concerns about any of the topics that we covered in this entire lecture series, please don't hesitate to leave a message for me, either through my website or by leaving a message in the comment section. This is the end of this lecture series, and I will be starting a new lecture series in the future. If you have anything that you are not sure about, please go back on my lectures, and I will leave a link in the description for the playlist for previous lectures from module 1 to module 16 and this module 17, and make sure you go through them thoroughly before you take your Cisco exams. And again, if you have any concerns or questions, please don't feel bad about reaching out to me, and I will make sure to answer all your questions. Until our next lecture series, good luck with your exams and have a nice day.